Recently, we discussed how to tell when triangles are congruent. Are these triangles congruent? Now, you might not have this on your note sheet, but just take a look at these triangles. I see these three sides have the same marks as these three sides, and these three angles have the same marks as these three angles. Therefore, I conclude that all parts from this triangle are congruent to all parts from this triangle, and therefore, yes, these triangles must be congruent. How about in this picture? Notice that I've left out this angle and this angle. Is this enough information to say the triangles are congruent? Well, before we said that when figures are congruent, all of the angles have to be congruent to all of these angles, and all of these sides have to be congruent to all of these sides. Do I know if these angles are congruent? That's one of our questions today. How about this amount of information? Two sides congruent to two sides. Is this enough information to say the triangles are congruent? How about these three sides congruent to these three sides? Well, before, we had to give a scenario like the first one. We had to say all of these parts are congruent to all of these parts before we could say the triangles are congruent. Well, today, I'm going to show you some shortcuts that help us to prove two triangles are congruent without needing all of the information. And here's our first one, the side-side-side congruence postulate. If three sides of a triangle are congruent to three sides of another triangle, then the triangles are congruent. What does that look like in a picture? Well, let's say side BC is congruent to side DE. Side AB is congruent to side EF, and side AC is congruent to side DF. That is enough information to say this triangle is congruent to this triangle, and therefore we can write a congruent statement. Make sure we match up the corresponding parts that are marked when we attempt to write this statement. Now, how do I want to write this first triangle? Maybe I go alphabetically. Triangle ABC is congruent to, but when I do the second triangle, I have to make sure I match corresponding parts. So if I went A, B, C, from A to B to C, I went here, and then I went here. I went over the double slash side, then over the single slash side. What path is going to take me over the double and then the single? This way and then this way. So that means I have to start at F. So I'm going to say triangle F and go towards E and then D. The point here being, we have only three sides congruent to three sides, then the triangles will be congruent. That is enough information. Now maybe you're asking yourself why? Why is that enough information? Well, ultimately, this is something we can explore in class, but just to give you a quick visual, I've got three sides here congruent to these three sides. If I try to change the side lengths, it won't change the fact that I can't make a different size triangle. If I try to make the three sides different, it's going to create a different size triangle. Let's go back to our list of postulates and theorems. Now we write for short SSS congruence postulate, but remember what that means. Side, side, side. Three sides congruent to three sides. Similarly, the SAS congruence postulate, or the side angle side congruence postulate, says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Well, what does that mean? Two sides and the included angle. Let's start with just two sides. So I'm going to take the two sides that I first marked here. BC congruent to DE and AB congruent to side EF. The included angle means the angle between. The angle that's made by connecting those two sides that have marks. This side that has a mark and this side that has a mark is connecting at angle B. B is the included angle. Similarly, this side that has a mark and this side that has a mark is connecting at angle E. E is the included angle. So according to side, angle, side, these two triangles can now be proved congruent. I can write a congruent statement just like I did before. How do we do it when there are angles and sides marked? Let's take a look. Triangle ABC, I might choose to start, is congruent to, now just like we did before, let's examine the path we take. ABC. So I go over the double slash side, hit the marked angle, and then go over the single slash side. Same idea that we did in the previous example. Follow the same path by looking at the marks. So once again, triangle FED. The point that we want to see here is that we have a limited amount of information. This time it's two sides congruent to two sides, the included or in between angle congruent to the included angle. Let's look at a couple more that are very much like each other. Angle side angle versus angle side. So again, these are shortcut letters, but it's angle side angle versus angle side. Now the question is, how does that look different? Here's how it's described. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Versus angle side says if two angles and the non-included side of a triangle are congruent to two angles and the non-included side of another triangle, then the triangles are congruent. So how does that look differently? Two angles in the included side versus two angles in the non-included side. Well, both of them have two angles. So let's start with the angles. I'm going to mark angle A congruent to angle F and angle B congruent to angle E. Notice that I'm using different types of angle marks. So I've got two angles. Now the included side. What does that mean, the included side? Well, included before meant between. Still means between, or we can think of connecting. Connecting this angle to this angle is this side. Connecting this angle to this angle is this side. That's how angle side angle looks. Now I'm going to mark for angle side the same angle A congruent to angle F and angle B congruent to angle E. Now, the included side is the side between or connecting. The non-included side is the side that's not between or not connecting. So if we look at the side that's connecting from A to B, that's this side. So I need to have marked one of the other sides, such as BC and ED. Notice how this is the side connecting angle to angle. Therefore, this is a side not between an angle, and a side. Similarly to how we wrote the congruent statements, I can do that here. Let's just try it for one of them. Triangle ABC. If I go from A to B and then to C, let's talk about the path that we took. We went from single angle mark to double angle mark and then over the slash. So similarly, single angle mark to double angle mark and then over the slash. So ABC is congruent to triangle FED, but for different reasons because of the path we took with those corresponding marks. Now, in case you haven't noticed, we've been using theorems, postulates that use 3 letters, such as SSS, SAS, ASA, and AAS. So hopefully you've gotten the idea by now that it has to be a combination of 3 things congruent to 3 things. Well, what about the combination SSA? Does that work? Let's look at a picture. So in this diagram, notice I've got 2 sides and an angle that's not between these two sides that are marked. So these two sides are congruent to these two sides. The included angle would be the angle connecting these sides, this angle right here. So it's not the included angle, it's this angle over here. Now let's go back to this picture for a moment, or SSA that I have here. So what I'm showing you is side congruent to side, second side congruent to second side, but instead of the angle being between, like SAS, like this one, it's not between, it's after. So these are different, two sides and an angle, but where the angle is placed is very important. If the angle is not connecting or included, so included means here, included means here, between or connecting. If it's not, so instead of it being up here, what if we put it not connecting, like down here? So let's go back to that picture so you can see what that's going to look like. Side, 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 and an angle not between. Well, these look congruent, but look at another way that I can keep this same congruent mark and see something not congruent. So I went from an acute triangle that has these two congruent sides to an obtuse triangle. Still has these two congruent sides, but notice that because this angle wasn't fixed, the side could go here or the side could go here. The point is, side-side angle is not enough information to prove that triangles are congruent. Now, there is one exception when it does work. Real quick, before we get to this exception, here's a helpful way to remember that side-side angle won't work. Spell this word backwards in your head. Yeah, creates a bad word, doesn't it? Let's never say that bad word, and we'll remember to never use SSA. So let's check out. Here's a time when you're going to ask the question about SSA again. HL congruence theorem. HL stands for hypotenuse leg. When do you have a hypotenuse? When you have a right triangle. So here's the theorem. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So I have to have a right triangle, so I'm going to put a right angle in this picture. The hypotenuse and leg have to be congruent to the other hypotenuse and leg. So I'm going to make the hypotenuse congruent to the hypotenuse, and one of the legs congruent to one of the legs in the other triangle. Well, if you're looking at this and you think about what we just talked about with SSA, you might be asking yourself, well, here's a side, and here's a side that have marks, and here's the included angle. This angle that has an angle mark is not included. So isn't this a case of side, side, angle? Isn't this the bad word that we're never supposed to use? Well, when it's a right triangle, we have no other option for how to swing that non-fixed side. So therefore, when it's a right triangle, SSA will work. But that's why we don't call it side-side angle. We have a better name for it, HL, the hypotenuse leg congruence theorem. But we have to have those two sides for a right triangle. For more information and to see these postulates or theorems in action, try visiting this website at Math Open Reference. So let's talk about which are the two combinations that we don't use and we haven't shown as postulates or theorems. Side-side angle we talked about, spells the bad word backwards is an easy way to remember it. Check out this website to see how that doesn't work. Angle, angle, angle is the other combination that we didn't use. Let's look at why that doesn't work. So here's a picture of three angles congruent to three angles. I can grab onto one of these vertices and make this triangle bigger. I still have, see how angle P and angle A are congruent to each other? all three angles are congruent to all three angles, yet if the sides are not fixed, if I do not have at least one fixed side, I can make the triangle as small or as big as I want, and still the angles will be the same. Now it'll be the same shape, the same kind of triangle, it'll just be different sizes. But congruent triangles have to be same size and shape. So SSA and AAA are the two we don't use. We have to have at least one side, and we can't spell the bad word. Now let's look at some examples and use our shortcuts. Determine which postulate or theorem proves the triangles are congruent, if any. Then write the congruence statement for the triangles when possible. So notice in these two triangles, I see an angle congruent to an angle. I'm going to write A by the angle marks. I see a side congruent to a side because of these hash marks. I'm going to write an S next to these congruent sides. I see a double hash mark here and here, so that means this side is congruent to this side. Now, these two angles do not have anything marked, and this side does not have anything marked. Similarly, in this picture, these two angles do not have anything marked, and this side does not have anything marked. Now I don't have to worry about which way to go around the triangle. As long as I don't pass over two x's in a row, I can go over any which way I want to. So if I'm going to start at this S, I can't go around this way because I passed too many x's, so I have to go around this way. So it's S, A, S, side, angle, side. If I tried to start over here and I go A, S, I pass too many x's before I get back to the other S. So these two triangles are congruent by side, angle, side. That's the postulate or theorem, one of our big fives. Now I'm going to write the congruence statement by matching up the corresponding parts. So starting in this triangle, I might start with T, go to K, and then V. After all, that's the order we went to see the side, angle, side. So I'll say triangle TAV is congruent. Now I want to do something that matches up the corresponding parts in the other triangle. Notice when I did TKV, oops, just notice that we needed to change this to K. TKV, I went over the 1 slash and then the 2 slash side. So I'm going to do the same thing over here. Starting with H, go over the 1 slash side and then the 2 slash side. H, M, J. Let's take a look at the next one. I see a right angle and another right angle. These are similar to congruent marks since they both mean that these angles are 90 degrees. So I have an angle congruent mark. Now I see a side mark and a similar side mark and another side mark. These are congruent as well. Now I'm going to put X's where I don't have an angle mark and where I don't have a side mark and where I don't have an angle mark. I'm going to do the same thing over here in the other triangle. There's no angle mark, there's no angle mark, and there's no side mark. So now when I go around the triangle, picking any letter, maybe I pick this S that's here. I can't go this way because that's two X's. I can pass at most one X. So here I can go this way. That would mean S goes to S and then to A. S, S, A. Now wait a minute. We're not supposed to use SSA. So let's think about this. When we have SSA, we want to ask ourselves, do we have right angles? And yes, we do. So if it's a right angle situation, that means we're using hypotenuse leg. Now we can write a congruent statement. So let's take a look at the first triangle and see the letters. We could say triangle UCB. Let's make sure we match up the corresponding parts in the other triangle. Notice to go from U to C to B, I went from the 1/ side over the 2/ side and down to the right angle. So similarly, I'll go W, E, F. Let's take a look at the third one. I have an angle mark, and it's congruent to this angle mark. I have a side mark, and it's congruent to this side mark. I have another side mark, and it's congruent to this side mark. Now I'm going to mark this and this don't have marks, and this side doesn't have a mark. This angle and this angle don't have marks, and this side doesn't have a mark. So now let's try to figure out which congruence theorem we're using. I don't want to go over too many x's, so I might start with this one over here. Side, angle, side. But wait a minute, when I try to look at it in this one, if I start at this s, I can't go this way because of the two x's, so I have to go this way. Side, side, angle. But that's not the same thing. This one has side, angle, side. This one has side, side, angle. Those don't match. These marks are not in the same place. Notice that these side congruent marks, when they join at the angle mark. But these two side congruent marks, where they join, there's an X there. There's no congruent angle mark. So since these are not in the same places, this one, it is not possible to write a congruence postulate or theorem and therefore a congruence statement.